Alright, today's lesson is 2.2. This is the relations portion of the cluster, and specifically we're going to talk about domain and range today. In the previous video we brushed on domain and range, but today we're going to focus on it. So this is page number 4 in your interactive notebook, and here's your lesson title. So what's the goal today? The goal today is to be able to identify domain and range of a relation in given either a graph, a table, or coordinates. So we're going to be given all three of these today, and our goal is to figure out what the domain or the range is. Get these key terms down again. I can't stress enough the importance of understanding what the domain and the range are, because they're just really important math concepts, not just specifically in algebra, but really in any subject in math. So domain is the set of all x coordinates that are in the relation, and the range is the set of all the y coordinates that are listed in the relation. And when you define the domain or the range, so for let's say domain, when you define the domain, you use this curly bracket to open it up. So the domain would be, let's say, 1, 2, and 3. Close the curly bracket, and then the range would be open the curly bracket 5, 4, and 6. So when you're defining them, you're going to use curly brackets, and then you're going to put the numbers in sequential order. So if the domain is 3, 1, and 2, you're going to put it in numeric order. Same thing for the range. That's just standard practice. So get your notes down, and we're going to go ahead and jump into the first example. So example number 1, what is the domain of this relation? And so with domain, remember, we're talking about x, so I'm going to give you some sort of way of remembering that domain is x. So let's say we've got this club that just opened up, and this club is called x. This is club x. And the bouncer to club x, this guy right here who stands outside and tells you, oh, you're on the list, you're not on the list, with his clipboard. The bouncer to this club, his name is domain, and he's only going to let you in to club x if you're a member. So if we look at these coordinate points, we've got to figure out which members, or which of the numbers, values, are members to club x, or which of the values will domain let in to the club. And if you can recall that all coordinate points, no matter what coordinate point you see, is always going to be in the form x, y, x, y, x, y, x, y. So if we're having to figure out who's going to be let into club x, it's fairly easy. We know that any x value will be allowed in. So we've got -5, we've got 8, we've got 11, and we've got -5 again. 3 won't be let in, that's a y. -2 won't be let in, 8 won't be let in, and 1 won't be let in, because we're again talking about domain, and domain is the bouncer for club x. So if we're going to list in numeric order the values that will make it into club x, we would start with the lowest number first. So here we have our domain. We're going to put it in squiggles, and we've got -5, 8, 11, and -5. Well, there's two -5s. We only need to write it once. -5 can only be let in once. It's got like a re-entry. Maybe he's got the re-entry pass. Then we've got 8, and then we've got 11. And that is the domain for this relation. So here we have example number 2. And we're talking about the range. So what is the range of this relation? In the previous example, we were given coordinate points. Now we're given a table, but nothing has changed, right? If we wanted to convert all of these to coordinate points, we can do so easily by just putting always happens, by putting a comma between them. We've got our x, we've got our y, coordinate point, coordinate point, coordinate point, coordinate point. So we can convert this table to a coordinate point, to coordinate points fairly easily. And we're talking about the range, and again, remember, range is y. I don't have a great example for range. So we know that if we're only talking about range, then all of these x values don't really matter, and we're only really concerned with the y values because the y values are the range. So let's go ahead and list them in numeric order. So we have our range. We've got 2, negative 4, 6, and 23. Well, negative 4 is the smallest number, then comes 2, then comes 6, then comes 23. And I'm going to go ahead and make a side note right here. This is just to help me remember that when I list the range or the domain, I always have to list in numeric order. So lowest to highest, least to greatest. Let's go ahead and get into example number 3. 2 more examples today. So here we have, what is the domain of this relation? And sometimes it's easy, if you're given a graph, to pick out the coordinate points of that graph and then figure out what the x values are, because we're talking about domain, what the x values are from that graph, and it's not showing up. So here we got coordinate point, coordinate point, coordinate point, coordinate point, coordinate point. What is the coordinate point for the first one? I'm really quickly going to list it. So we've got x is negative 5, y is negative 5. So we've got negative 5, negative 5. For j, we've got negative 3 for x and negative 1 for y. So negative 3, 1. Negative 1, sorry. We've got 1, negative 5. We've got 3, negative 5, and we've got 5, negative 5. So if I just wanted to convert the graph to coordinate points so that I can easily see, if we're talking about domain, we're only talking about our x values for this relation. So the domain here, and I'm putting them in squiggles, and I'm putting them least to greatest. So we've got domain, 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 domain. And the smallest number will always, if you're given a graph, will be the farthest left, because we go from least to greatest on our coordinate plane. So it'll be negative 5. Then comes negative 3, then comes 1, then 3, then 5, and that is the domain of this relation. Here's our last example for today. And here we're talking about range. So we've got our coordinate points again. This time I'm not going to list them out. What is the range? Why does that always come up? This computer wants to fight. Alright, so we've got range here, so we're only looking at the y values for range. So the y value for this point right here is negative 5. We've got a point right here. What's the y value? Looks like the y value is at negative 1. So these 2 points are gone. The y value for all 3 of these points is going to be the same. Again, it's negative 5. So we've got 4 y values that are negative 5, and we've got 1 y value that's negative 1, and we don't need to write negative 5 multiple times. Okay, we don't need to be repetitive. We just need to write it once. So negative 5, comma, negative 1. This is the range for this relation. Good luck on the homework. If you have any questions, please feel free to message your classmates or I in Schoology.